Hey kids, Miss Kulkarni here. In this video, we're going to move on with organic chemistry and actually learn how to name a given alkane and also how to draw a structure if we know the name. Now, alkanes could be a regular straight chain alkane or we may have a branch alkane. Whatever the case may be, our job is to find out the parent name for the chain. And how do we find out? We look at the number of carbon atoms and we need to find out the longest possible chain in that organic molecule. If we have branch substitutes, then we number the carbon atoms so that the substituent gets the least smallest number. Also, if there are two chains and they have same number of carbons, then we always take the parent chain with maximum substituents. And we will work on some example so all these rules will become very clear. The next rules, we need to make sure that the carbon atoms are numbered always from the nearest first substituent, not from the other side. Now, what if we have two substituents and there are same number of carbon from both the ends? The numbering will begin in this case from the end which is nearest to the next substituents. Okay, let's look at the next rule. When we are naming that branch substituent, we always put that in parentheses. And then we also put the number of the carbon atom where it is connecting. Now, what happens when we have multiple substituents of the same type? We use the prefix which tells us how many of those groups are there. Like for 2 we use di, for 3 we use tri, for 4 we use tetra, and so on. So if we have 2 methyl groups, we can easily use the word dimethyl. If you have 3 chlorine groups, we can say trichloro, and so on. Look at the first compound. Our first task is to find the longest chain. And I can clearly see that I have this as the longest chain, which is equal to 6 number of carbon atoms. So 6 stands for hexa. So I can write down that hexa there. The next step is to number the carbon atoms. But before that, look at this. We have a substituent which is CH3, or we call that as a methyl group. Now methyl is attached to this carbon atom and our job is to get the smallest number for this carbon atom. So if I begin numbering from this end, I get 1, 2 and so on. So we got methyl group attached to second carbon atom number. So this is going to be an hexane for sure, and we got at position 2 methyl group. So it is 2-methyl hexane. Let's look at the next example. And you know the substituent is right over here. It's 2 carbon atom. That means it will be ethyl. And the numbering should be beginning such that this carbon atom gets the least number. So what's the answer? It will be 2-ethyl and it's going to be hexane again. Look at the next compound. That does look tricky. So if I want to find out the longest chain, I can clearly go zigzag like this, and that is the longest chain. So how many carbon atoms we got there? It's 1, 2, 3, 4, 5, 6, 7, 8. That means I have an octane. Now this is the substituent which is attached. The carbon atom number over here should get the least number. So if you go from the right side, it's 1, 2, 3, 4 and 5. Whereas if you go from the left side, it's 1, 2, 3, 4. Remember, we need to get the least number. That means it will be 4. And then we got methyl group, so it's 4-methyl octane. Look at this compound. And your job is to find out the longest chain, which is kind of in zigzag manner. So how many carbon atoms we got? 1, 2, 3, 4, 5 and 6. That means you have a hexane there. Now we are not done, because we got one methyl group here and second group over here. Our numbering should be such that the carbon atom that has a substituent should get the least number. So if we start from left hand side, it's 1, 2 and 3. At carbon atom number 3, we got a methyl group. How about beginning from this side? If I do 1 here, that will be 2, and 2 is of course smaller than 3. So I'm going to continue and number it as 1, 2, 3. This is 4, this is 5, and that will be 6. So we got 2 methyl groups now, one at position 2 and second at 4. We can connect those together and we can say it is 2, 4, and we got 2 methyl groups. So it is dimethyl and it will be hexane. What do you think? Now let's find out how to draw the structures if the name is given. This is 3-methyl pentane. Penta stands for 5. That means we should have a chain of carbon atoms which is equal to 5. At position number 3, we have a methyl group. So if I number it 1, 2 and 3, at 3, we should have a methyl group. That's the skeleton ready for 3-methyl pentane. Now the only remaining thing is to make sure each carbon has the hydrogen atom which will be required to make 4 bonds. And there it is. We ended up getting 3-methyl pentane. Let's work on the next one. It's hexane. Hexa stands for 6. So let's make a straight chain with 6 carbon atoms. And let's number it. So this is 1, 2, 3 and so on. At position 2, we got a methyl group. At position 3, we got the ethyl group which is CH2, CH3. And now we need to just make sure every carbon has the correct number of hydrogen atoms. And there it is. We got the correct structure. Let's draw one more molecule. This is heptane and hepta stands for 7. So let's make a chain with 7 carbon atoms. There we go. Let's number that. And at position 2, we got methyl. So let's write down that as CH3. At position 3, we got propyl. Propyl is C3H7. And then make sure we got correct number of hydrogen atoms. And we are ready, set and go. So by this time, you know how to name a straight chain alkane or a branched alkane. How about naming a cyclic alkane? Basically, we follow same rules. We need to find out the parent name that's based upon number of carbon atoms, and we simply need to add the word cyclo. So if it is 6 carbon atoms and there is a chain, we call cyclohexane, and so and so. Now just keep in mind, sometimes the ring could be attached to a straight chain alkane, and at that point we consider ring as the substituents. We can also have 2 rings attached to each other, and the larger ring is always considered the parent and the smaller one is considered as a substituent. One more rule: if we have the carbons of the ring are numbered, we have to make sure the substituents are given the lowest possible number. Okay, let's practice some cycloalkanes. Look at the first figure. Number of carbon atoms over here clearly are 5 because it is a pentagon. And if it is 5, the parent name is going to be pentane. It is cyclic pentane, so I can add the word cyclopentane. And there is a methyl group attached. That's the only group there. So I'm going to put that as 1-methyl cyclopentane. How about next one? The ring has 3 carbon atoms. With 3, the word is prop. So it is propane. Since we have a ring, it is cyclopropane. And the substituent which we got is with the 2 carbon atom. That means that must be ethyl group. And that's only 1. So we can say 1-ethyl cyclopropane. How about the next one? We got 2 substituents there. The ring has 6 carbon atoms. So that means it will be cyclohexane. And we got 2 substituents, methyl and ethyl. As a rule, we should begin with the one which alphabetically comes first. So it will be good to number this as 1, this as 2, 3, 4, and so on. So at position number 1, we got a group which is ethyl group. And at position number 2, we got a methyl group. So there you go. That's the name. 1-ethyl, 2-methyl cyclohexane. Let's do reverse way. Here we are going to draw the structure. It is butane. That means it corresponds to 4 carbon atoms. It's cyclobutane. So the structure will be a square like this. 1-methyl. That's the only substituent, so you can number that 1-methyl. We only have 1 substituent and you can number that anywhere you want. So if that is 1, we should have a methyl group attached to that. So guess what? You learn naming straight chain alkanes, branch alkanes and cycloalkanes. And on top of that, you also learn drawing the structure if the name of the organic molecule is given to you. So I hope you guys are ready to work on some practice problems. I'll see you again in next video. Until then, bye-bye.